Hi everyone. Today we're going to study the parabola with vertex at HK and opens to the right. Let us first define a parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and a fixed line is called the directrix. Let us now consider a parabola with vertex at HK and opens to the right. Here we can say parabola. Here is the vertex at HK, and we pick one point of the parabola and put the coordinates xy. The standard equation of parabola with vertex at HK and opens to the right is here. And this is the square of the quantity y minus k equals 4a times the quantity x minus h. Let us write again that the vertex is at HK. We know that this a here is the distance between vertex and focus or directrix. We can write now the coordinates for the focus, and the x coordinate is h plus a, and the y coordinate is k. In our graph, this is the focus. Next is the directrix, and the equation is x equals h minus a. This is now our directrix. The axis is the line y equals k, and this is the axis. Remember, axis is the line perpendicular to directrix and passing through focus. Now we have the length of latus rectum equals 4a. This 4a is the coefficient of the quantity x minus h in the standard equation. Remember that latus rectum is the chord drawn perpendicular to axis and passing through focus. Here in our graph, this is the latus rectum. Now we have the endpoints of latus rectum. We have these two endpoints whose x coordinate are both h plus a, and the y coordinate is k plus 2a, that is for this point, and the other one is k minus 2a, that is for this point. Let us see this example. Find the equation of the parabola with vertex at the point -3, 2 and focus at 4, 2. Sketch the graph. For our solution, this is a parabola with vertex at -3, 2, and since focus is at the point 4, 2, the parabola opens to the right. We have now this parabola that opens to the right. The vertex is at the point -3, 2, and this is now the focus 4, 2. Let us write the standard equation of the parabola, and it's here now. And then we can take the distance from the vertex to focus, and this is a equals 7. Let us substitute the vertex and the value a to the equation, and we have now the square of y minus 2, that is for this y minus k, and the quantity is squared equals the 4a here now becomes 4 times 7 times the quantity x minus h. So we have now x minus negative 3. Simplifying further, the 4 times 7 is 28, and this x minus negative 3 becomes x plus 3. So this is now the equation that we are looking for. Let us now discuss further the parabola. Writing the given, the vertex at negative 3, 2, and the focus at 4, 2. A while ago, we learned that a equals 7. It is the distance between the vertex and the focus. We can now write the directrix, and the equation is x equals h minus a. Substituting the values respectively, we have negative 3 minus 7. And simplifying this, we have negative 10. So the equation of the directrix is x equals negative 10. This is now the directrix. Let us now write the length of latus rectum, which is 28. We took this value, and that is the coefficient of this x plus 3 in here. Now, let us have the endpoints of latus rectum using this formula, h plus a for the x coordinate, comma, and the values k plus or minus 2a for the y coordinates respectively. So the points are the 4, 16, and this is that point, and the other point is 4, negative 12. This is the other endpoint. For the axis, the equation is y equals k, and our k here is the number 2. So the axis is y equals 2. This is the axis. This is now our final answer. I hope you learned something from this video. See you again next time.